Okay, tell me, how can we prove that the cos 4x is equal to 1 minus 8 sine squared x, the right hand side? So Katli is saying that the right hand side is the one that is, please repost after. Okay, right side is complicated. So everyone is saying that the right hand side is complicated. The right hand side. Yes, I'm not at home. No books for notes. Oh, okay. Oh, Evelyn, we attend everywhere. Nice. Guys, will you be happy when I say that on the right hand side there's nothing much we can do? Thank you, user 4638. You are very correct. The side that we need to work on is the left hand side. No, left. Yes, you see the left hand side is the one that we can work on. So my left hand side, it's equals to the cos 4x, and someone for sure they are asking, how can we prove that this cos 4x is equal to 1 minus 8 the sine squared cos squared x? Please just follow the instructions. We know that we can break the 4x as what? This 4x will be the cos of 2 into 2x. Double angle, yes, this will be the double angle for cos. So what I'm trying to say is that if this is the double angle for cos, meaning that we can write this as, this is the same as the cos 2a. That a is x, is 2x. Please note that, né? The a is 2x. Monday, thank you very much. Okay, so now what I'm going to do, if I have this as the cos 2x, what's next? I need to choose, listen, I need to choose the identity between these three identities that we have here. We need to choose one identity that we can use. We need to choose one identity that we can use. So now, how do we choose the identity? It's very important how we choose the identity. Look at this. When we are working on the proof, we need the product of sine x multiplied by cos x. We need the product of sine x multiplied by cos x. And the only way to find that is to make sure that we have what? Is to make sure that we have the sine 2x. So we know that the sine 2x is the one that is equals to the cos, I'm sorry, not 2, but is the this one. I'm just trying to say that whatever that we do, we need to bring the sine 2x. This is the only way we can prove this. So we're going to choose the, what is this? We're going to choose the identity that will bring us the sine 2x. So this tells you that we need the identity that has only sine x on that identities. At Mpelishe, maybe yes, because that's a compound. This question deals with double angles. Will 2x plus 2x be wrong? It depends on your aim, né? Most of the time when, let me guys fix this. Most of the time when you prove, it depends on the aim. What is your aim? It's very important that you understand your aim, okay? Okay, I'm sorry about that, but let's continue. Yes, someone said it. It depends on your aim. It depends on what is your aim. So now I'm going to choose the one that has only sine x. Let's go and see which one has only sine x between our identities. So the one that has only sine x is going to be this one. So this is the identity that we're going to use, which is 1 minus 2 sine squared x. So this will be equals to, we're going to change this into 1 minus 2 the sine of what? The sine squared of that angle. What is your angle? Your angle is 2x. please, your angle is 2x. So now I can rewrite this and say this is 1 minus, then you see the 2, remember the squared, it's on that sign, it's on that side. So I can just write this as 2, then inside the bracket I have sine 2x squared. So what we are trying to do is that we are trying to create that sine 2x, and this is the best way to create the sine 2x. I think everyone understand what happened here, and this is squared. So remember, the sine squared 2x and the sine 2x everything squared is just the same thing. So my aim to bring the 2 outside is for us to get that sine 2x. So because if we have the sine 2x, we know that this guy will change into 2 into 2 sine x, the cos x. Then what happens from this? Everything is squared. So it's 2 squared, that will give us 4. So inside the bracket I have this as 4. Sine squared, this will give us the sine squared. X, the cos squared, this will give us the cos squared x. Because if I have a multiplied by b squared, I need to multiply everything inside by the squared. So this will be ab squared. So that's why everything inside the bracket is to the power 2. I hope everyone is happy with that. Né? So far so good. We already have the answer. Look at this. We are trying to prove that this is 1 minus 8 sine squared x, the cos squared x. And I can see that inside the bracket I already have my sine squared x, cos squared x. Multiply the bracket by 2. 2 times 4, that's 8. And then sine squared x, the cos squared x. Therefore, left hand side is equals to right hand side. Are you all happy with that? Guys, you see, if we can increase the bright, we'll be able to see properly if we can increase the bright. But let me see, do you guys have any questions? Do you guys have any questions? Okay, everyone is happy. Can we do more questions on proof? How do you know which formula to do? Kathy, I'm coming. I'm coming to your question. Bianca, sir, can you please repeat this question? Okay, Bianca, we're going to work on it now. So let's go back to Kathy. Kathy is asking a very important question here. Say, how do you know which formula to use? So look at this. This is how we know which formula we need to use. Né? Look at this. Maybe we should just start by explaining this formula part, because if you can master the formula part, then that's when you're going to know which formula to use. Let me explain this. Né? Remember the cos 2x is equals to the cos squared x minus the sine squared x, which is also equal to the 2 the cos squared x minus 1, which is equal to 1 minus 2 the sine squared x. So look at this. These are my 3 formulas for the double angle of cos. Né? Kathy, this is how you choose your formula. Listen very much. Né? I'm sorry. Listen very much. Listen careful. Né? So this one, that one, we're going to use it if you ask yourself, what do you see before or after the cos 2x? That's what you need to ask yourself. What do you see before or after the cos 2x? What do you see? So if you see the sine x, that is multiplied by the cos x, you're going to use that formula. Okay, and then this formula, we use it if we have the cos x before or after the cos 2x. You're going to see on the question that we're going to start with. Né? This formula, we use it if we see the sine x. Okay, right. So now listen, you see these two formulas. This one, if before or after the cos 2x you have 1, you use this formula, because this one is negative. So when you add these two, you get 0, so that we can get rid of that 1. And if you have minus 1, you're going to substitute this formula, because this 1 and the minus 1 will give us 0. So now you know that if you have 1, you're going to use 2 cos squared x. Let's go back. Look at this. Look at what happened on this problem. We solved the problem, and then on top we had 1 plus cos 2x. This is what we had on top, 1 plus cos 2x. So you ask yourself, what do you have before or after the cos 2x? We have 1. So we have 1. We need to choose the formula that will get rid of that 1. So we need to choose the formula that has negative 1. So between these three formulas, which one has negative 1? This is the formula that has negative 1. So we need to substitute this as 2 cos squared x minus 1. Why? Because we are trying to get rid of that 1. So I think you understand why we used this formula here, why we choose the 2 cos squared x. Okay. So now I did try to explain when to use each formula. Né? Let's apply this on the next example. But before we go to the next example, I'd like to answer Bianca. Né? Bianca is saying, sir, can you please repeat the question? Bianca is asking if we can do this question again. Né? So let's work on it very fast before I check on the other comments. Né? Bianca, let's hope you are still in the lesson. Né? So they want us to prove that the cos of 4x is equals to 1 minus 8, the sine squared times the cos squared x. So to prove this one, the first thing that you need to ask yourself is that which side is more complicated, or which side can we work on? We chose left hand side because we believe that left hand side, this one, the cos 4x, is the one that we can be able to manipulate to get what we are looking for. Okay, I hope everyone is with me on that. Né? So now look at this. I know that the cos 2x, I can create a double angle for that cos 2x. I can create a double angle and say this is the cos of 2 into 2x. So this is the double angle for what? We can say this is the double angle for cos. Let's say this is 2a. We know that the angle A is 2x. Thank you, Surprise, for the gifts. Thank you very much. Okay. Now, what's next? Look at this. If I go up now, I need to choose which identity I need to use. So I'm going to, you see, when it comes to proof, when you choose your identities, make sure that you look at your aim. What are you looking for? On your solution, we need to have the sine times cos. We need the product of sine and cos. So the product of sine and cos, we can only get it if on our problem we have something like this. We have the sine 2x. So if we have the sine 2x, we know that the identity of sine 2x, we can just equate this and say this is 2 sine x, the cos x. So what I'm trying to say is that in order for us to get this product, we need to create sine 2x on this equation. So how can we create sine 2x? Already we have the angle as 2x. We need to choose sine on that formula. So we know that the cos 2x, this cos 2x, we're going to substitute it as 1 minus 2, the sine squared of that angle. Okay, so now this can be written as what? We're going to write this as 1 minus into the sine squared of that angle, which is 2x. Remember, the aim now is to create the sine 2x. How can we create the sine 2x? We need to take the square out. This will be 1, 2. Open the bracket, write this as the sine 2x, and then the square, I'm just going to take it out. So now I'm happy because I have that sine 2x. So since I have that sine 2x, I can just say, remember, what is the sine 2x equals to? Is 2 sine x the cos x. 2 sine x the cos x. So I'm just going to substitute that and say this is 2 into 2 sine x the cos x, and everything is squared. So if everything is squared, this will be 1 minus 2. Look at this. 2 squared is 4. Sine x squared is sine squared x, and cos x squared is cos squared x. Can you see that inside the bracket? We have that sine squared, cos squared. We just have to multiply out the bracket by what? We just have to multiply out the bracket by that 2, which gives us 8 sine squared x, the cos squared x. And that's it. Left hand side is equals to right hand side. Right. I'm just gonna try and answer the next question. So let me see if maybe I missed a question. Junior, thank you, Surprise, for the gifts. Much appreciated. Okay, I think everything is good. I think everything is good. So now look at this. Look at this. Now you know what we're going to do. Let's try another example so that you can see how choosing the formulas work. Let's try and work on another example so that everyone can see how we choose the formulas. So let's try and prove that. Let's prove that prove that the sine x minus the sine 2x and everything is divided by 1 minus the cos x plus the cos 2x. This is equals to negative the tan x. So when you do your proofs, I need you to also consider what you are trying to prove. Look at this. I know that the tan x is equals to sine x over cos x. So what I have in mind is that, okay, Bianca is asking that after proving this question, can we go to general solution? Yes, we can. Remember, we're just focusing on what you guys are struggling on. And if Bianca, you believe that going to general solution is the best, we'll definitely do that. Don't worry. Yes, we'll do more. Remember, this is one of those double angle questions. This is one of those double angles. So look at this question. Look at this question. So we need to prove that this side is equal to that. But now I know that tan is sine over cos. So the aim on top is to only have sine. And the aim on bottom is to remove everything so that we can only have cos. That's the aim. User 4321. I'm not sure how long we're gonna go live, but I think most of my students, they know that once I get tired, I'll be like, okay, this is the end for today. This is where we're going to stop. They know. We might even stop after this example. I'm kidding, but I don't know how long we'll go for. But let's try and push. It's Saturday after all. Yeah. So let's do this now. if I have this, remember someone asked, how do we know which formulas to choose? So now I'm going to teach you how to know which formula to choose. Né? We go back up, ask yourself, what do you see be? Oh, this one, we know that this one is non-negotiable. The one on top, the sine 2x, it's equals to, so this can be the sine. Oh, we're going to work on left hand side. I'm sorry, we need to choose the side, the most complicated side, and I'll go with my left hand side, which is equals to the sine x minus, I know that the sine 2x, I can change it and write it as 2, the sine x, the cos x, and everything is divided by 1 minus the cos x plus. Right, welcome guys. Thank you for the follow, user for the 321. We'll make sure that you feel at home. Né? Thank you for joining the family. We'll make sure that you feel at home. So look at this, guys. Now I need to choose the double angle that I can use for this cos 2x. I need to choose the double angle. So now this is how you choose the identity. Let me show you guys how you choose the identity. Okay. So when we choose the identity, let me go back. I have these identities. Michelle, thank you for the follow. We'll make sure that you feel at home. Né? Thank you for joining the family. So look at this, guys. I have this as the cos 2x. I need to choose the best identity to use. And to choose the best identity to use, you know what I'm going to do? I check what I have before that cos 2x. I have cos x, and I said that if we have cos x, we're going to substitute the identity that has only cos. Let's go back. So the best identity to choose, look at this. We have cos before the cos 2x. We have cos before the cos 2x. The identity that we're going to use is 2 cos squared x minus 1. I hope this makes sense. Né? So if this is cos, the identity that we're going to choose is 2 cos squared x minus 1. Okay, so now let me go back down. YA. Tanko, you're asking why what? YA. Please try to send that question again. Eh? So we are saying that we'll change this. I'm just going to put this inside the bracket. This is 2 the cos squared x minus 1. So this is my identity that I'm going to choose. So now please, why that identity? Remember, the reason I'm saying why that identity is because I'm saying that the reason we are choosing this identity, we check what we have before or after the cos 2x. So since we have cos, we're going to use the identity that has only cos. Guys, please, it's very important that you understand how to choose your identity. What do we have before cos 2x? We have cos. So the identity that we use is this one, the one that has only cos. This is the identity to use. Very important. Né? Right. So now I'm just gonna substitute that and say this is equals to. The reason I have this inside the brackets is because in case if this was negative, because remember if this was negative, we will have to multiply out the negative. I'm not sure who's this, but thank you for the follow. Thank you for joining the family. We'll make sure that you feel at home. So now, what I'm going to do now, the reason I put this inside the bracket, just in case if the sign was negative, because we'll have to multiply out the bracket by negative. Elishaba, thank you for the follow. Né? We'll make sure you feel at home. So now I have this as sine x minus 2 the sine x, the cos x, and the bottom part, I still have 1 minus the cos x. Because the sign is positive, nothing will change inside the bracket. But if it was negative, the sign inside the brackets were going to change. Now look at the 1 and the minus 1. I think now it's quite obvious that these two guys, they're going to cancel, né? The 1 and the -1, they're going to cancel. Right, the 1 and the -1, they're going to cancel. But now, just to save time, look at what we have on top. We have a common factor. And what is our common factor? Sine x. So I'm going to take out my sine x as the common factor. Right. The sine x as the common factor. So remember, when you take out, okay, let's bring this question down here. When we take out the sine x as a common factor, né? Whatever inside the bracket, this side, where the sine x, we're going to replace this by 1. Where the sine x, we're going to replace it by 1. So what I'm trying to say, I'll be left with 1 minus 2 times 1, the cos x. Close the bracket. Then let's go to the bottom part. Look at the bottom part. Cos. I also have the cos as a common factor, but I'm just gonna take it that negative cos out as a common factor. So I'll have this as negative, the cos x as a common factor. Please, what I need you guys to ask now, what I need you guys to ask me is that what will happen if, why are we taking out the negative cos as a common factor? Because remember the aim, to have cos on bottom and sine on top. But look at this. The tan has to be negative, so that's why I'm going to take also the negative out as a common factor. Then I'll be left with 1 minus the cos x. So look at this. This is just 1 minus 2 the cos x. These two cancels. I'm left with the sine x over negative the cos x, which is just negative the tan x. Therefore, your left hand side is equal to right hand side. Oh, I see. Left hand side is equal to right hand side. And that's how it is. Someone requested that we also do general solutions. Né? So now, someone asked that we do general solution. Listen, this is what we're going to do. Né? From the very same question, this one, you see this question, we're going to add general solution. Perfect one, more say. Don't worry, we'll do more. Né? When I just make sure that you are taking notes. If there's something you don't understand, you are definitely recording the lesson. You'll have the chance to watch it later. Né? Right. Before you go to general solution, please do mixed identities. Kathleen, when you say mixed identities, what do you mean? Because we already did mixed identities. But let me try to write something down. Maybe this is what you need. Né? Let's do one more. Né? Prove that the root of 1 minus, I'm not happy with this one, because I think we did this one on this other life, but let's do it again. Cos squared 2x, the root of cos squared 2x over the cos, minus x multiplied by the cos of 90 degrees plus x. And we need to prove that this is just negative 2. Kathleen, is this what you want? Let's push, guys. Please tap the screen. If you are not part of the family, make sure that you follow us, and we'll make sure that you feel at home. Kathleen, I think this is the type of the question that you are looking for, because remember, we have negative angles, we have cofunctions, we have identities. So I think this is what you are looking for. Né? Let's try and work on it. Let's try and work on this one. Né? Look at what I have on top. So my aim, I know that I need to get rid of the square root. Can you see that my answer? I don't have any square root. Sure, Kathleen, don't worry, we'll work on it. Né? I don't have a square root. So now the aim is to do what? The aim is to find the square root. is to remove the square root, and this is how I'm going to remove the square root. Please pay attention on this. Now, remember that we have an identity that says the sine squared of theta plus, or maybe we should just, okay, plus the cos squared of theta. This is equals to 1. So now look at this. 1 minus cos squared 2x is the same as the sine squared of theta. It's equal to the cos will go to the other side to change into 1 minus the cos squared theta. So can we say that our theta here is 2x? We can say that our theta is 2x. As you can see, we can say our theta is 2x, meaning that inside the square root, we can change whatever that we have inside the square root by applying this identity. We know that the sine squared of that angle, so inside the square root, my left hand side, it's equals to, maybe we can just put this here, left hand side is equal to, inside the square root, I can have this as the sine squared of that angle, which is 2x, and everything is divided by, now look at this, the cos of negative x. This is in quadrant 4. How is cos in quadrant 4? Positive. This will change into positive, the cos x. What about this 90 plus x? This is a cofunction. Cos changes to sine. But where is this? This is in quadrant 2. How is cos in quadrant 2? Because remember, if we have 90, we are adding. We are adding something will fall into quadrant 2. So this it will change into negative, the sine x. Okay, so now everything is good. We can just quickly simplify the top part. So the top part, remember how we can remove the square root? We can write this as the sine 2x, everything squared. Remember, we still have the square root there, and then this is divided by, I'm just going to bring my negative and write this as negative sine x times the cos of x. I hope everyone is happy. Now, I know that the square root cancels. The top part, I only have the sine 2x over negative the sine x, the cos x. The top part is a double angle for sine. We can change this as 2 the sine x, the cos x, this is divided by negative the sine x, the cos x. So these two cancels. The answer is negative 2, because negative 2 divided by 1 is just negative 2. So we've managed to prove that left hand side is equal to right hand side. Okay. I want us to go back to, but before we go back to the previous one, I want you guys to tell me if you have any questions. Do you guys have any questions? Kwaito, welcome. Do you guys have any questions? Please scroll down, say. Nope, for me. Okay, surprise, nice. So this tells me that you understand everything, and I hope everyone is taking the notes. Né? Rico, get in. So now you know what I'm going to do. I want us to go back up, because there's something someone said, let us do general solution. So I want to show you how they ask general solution. Trust me on this. They will start asking you by the identity, to prove an identity. Then when you are done proving the identity, they'll want you to find the general solution. Okay guys, let's tap the screen. Let's hit the 20k likes. Né? Let's hit the 20k. Right, so now look at this. I'm just gonna go back to that first question that we were working on. This question, né? We already did the proof, but I'm just gonna rewrite the question down so that we can answer the following questions. Okay, I think it would be best if we just start the question this side. Okay, we were working on the sine x sine x minus sine 2x one minus the cos x plus the cos 2x. And remember, this was equals to what? This was equals to negative tan x. Okay, so on this question we already did the proof. We already did the proof. Okay, I'm happy with that. I'm happy that we already did the proof. So now this is how they will ask you to do the general solution. Look at the question. So when they ask for general solution, they'll say that for which values of x to be an element of 0 and 180 degrees is the identity not valid. Guys, when you see this question, just know that this is what? This is an identity. Just know that this is an identity. I hope everyone understands. This is a general solution. I'm sorry. So first thing first, they'll ask you to prove for the general solution. Then they will say for which values of x is this. Okay, so if guys, let's push the live. If we're not hitting 20k likes before we finish this problem, we're just gonna call it a night. So if we don't hit 20 likes, this is where we're going to stop. Okay, so now when they ask, when they say for which values of x is this, for which values of x is this identity not valid, let's first explain what is the question saying. Not valid, it's equals to, so this guy not valid, it's equals to undefined. They are asking where is this undefined. I'm just gonna take you back to grade 11, back to grade 8. Yeah, let me take you back to grade 8. Listen this, in grade 8 you said that if you have a fraction a over b, if b is equals to 0, then this is what we call this undefined. So 0, if the denominator is equal to 0, then this will be undefined. So in order for you to answer this thing, you take whatever that you have on your denominator. You're going to say whatever you have on your denominator like this. This is your denominator. Whatever that you have, you equate it to 0 and then you solve for your general solution. Right. So I'm just going to take my 1 minus the cos x plus the cos 2x. This is equal to 0. Then we need to solve. So this is a general solution. We need to work on that. This is a general solution and we need to work on it. Right. So now, when we solve this thing, remember I said, what do we see before the cos 2x? We see cos. So the identity that we substitute is the one that has only cos. So this will be 1 minus the cos x plus 2 the cos squared x minus 1, close the bracket. This is 0. Right. So now I know that when I multiply out the bracket, this is same as 1 minus the cos x plus 2 the cos squared x minus 1, and this is equal to 0. Therefore, look at this. The 1 cancel. We know that the 1 cancel. We are left with negative the cos x plus 2 the cos squared x, and this is equal to 0. So we talked about taking out negative. The cos x as a common factor, I'll be left with 1 minus 2 the cos squared x, and this is equal to 0. So I think everyone remember where is this coming from now. From the previous question, we had something like this. Okay, so I'm sorry, this is not cos squared, but this is just cos x, because we have the cos out as a common factor. We can use the zero product property, saying minus, when we say the zero product property, this is what we are referring for, to minus the cos x, it's equal to 0, or 1 minus 2 the cos x is equal to 0. This side, when we solve, the cos x is 0. We need to find our reference angle. So my RA is equals to the cos inverse of 0. If you put that on the calculator, you'll find your reference angle to be 90. We are coming back to that side. Let's solve this side. So let's take the 1 to the other side, so that I can have negative. The cos x is equals to negative 1. Divide both sides by 2. I'll have the cos x is equal to 1 over 2. Therefore, if I have it like this, what is x equals to? What is my reference angle this side? What is the cos inverse of half? Is just 60. So I guess you guys understand where is this coming from there. I guess you guys understand where is this coming from. We have the reference angle for that cos is equal to 0, and the reference angle for this. So to determine our general solution, first thing first, cos is equal to 0 is positive. In which quadrant is cos positive? First and fourth. We are coming back to you, my guy. We are coming just now. We're going to work with you. Don't worry, we are coming. So now what I'm going to do is that I need to work on this side. I need to work on this side. So this side, I'll say x is equals to, in first quadrant, let's say this is quadrant 1. So in quadrant 1, x is equal to your reference angle. We add k times 360. Then you're done for quadrant y, k times 360. So now, if this is x, this will be x. It's equal to my reference angle, it's 90 plus k times 360. Then you are done answering that question for quadrant 1. We need to do this for quadrant 4. Q4 is 360 degrees. We minus reference angle. We add k times 360 degrees. I hope everyone understands that part. So this will be 360. We minus 90 degrees plus k times 360, and we get this to be 360 minus 90. This is just 270. We add k times 360. I hope everyone is happy with that. Whatever that we did this side, whatever that we did is the same process for this one. We're going to apply the same process for this one. So our reference angle is 60, but look at the cos 1 over 2. It's positive. In which quadrant is cos positive? 1 and 4. Remember, in quadrant 1, we just have x. Okay, Q1, this is x. We add, so this will be equals to my R. Oh, come on. What's going on? Okay, RA, we add k times 360 degrees. Therefore, this will be 60 plus k times 360. Then we done solving that problem. We done solving the problem. Then, when I move to quadrant 4, what do we have in quadrant 4? So quadrant 4, we have the reference angle. Okay, quadrant 4 is 360. Quadrant 4 will be 360 degrees. We minus our RA times, we're going to add k times 360, and that's it. What is your reference angle? What is your reference angle equals to? This will be 360 minus 60 degrees plus k times 360. So now this is just 300 plus 300 plus k times 360 degrees. Okay, I think I'm happy with that now. I think I'm happy with that. And then now, okay. Okay, let's fix something this side. Yes, we add k, and also that k must be an element of real numbers. Now please, surprise, you are right. N must be an k must be an element of real numbers. Thank you very much for that. Né? I think everyone will do that. All right. So now this is the end, guys. This is the end. This is how you solve the problem. But the issue is that I wanted to move fast. But the issue is that we are not done solving the question, because when I go back, I remember they said x must be an element of 0 and 180. Danko, you can also use n times 360. Né? Even if you use k, you can use n. I know most of the time you at school, guys, you use n. Né? You can do that, don't worry. You can do that. So now we are not done solving the problem. Né? We are not done solving the problem. So now look at this. The question said your n should be an element of 0 and 180. Okay. N must be an element of 0 and 180. Look at this. I'm just going to say this is guys, I'm just going to give you instructions, né? What to do. You're going to substitute the following values, né? You're going to substitute the following values. Guys, I see you guys beat me with the 20k and I'm tired, but it's fine, because now that you guys beat me with the 20k, we'll set another target. Yeah, I just want to answer Elite Academy metric rewrite. For which app am I using to teach? Guys, how do I do this? Oh, nice. Elite, it's not an app, né? Surprise was that my school wasn't taught art, so it's my first time. Oh, okay. Elite, it's not an app. It's just SP Pen. See, you just have to set it up on your computer. It's SP Pen. So yeah, this is it. It's an SP pen. So when you buy it, it comes with this pen, and then you just have to connect it on your laptop. Then you open your, what is this? Yeah. I hope you are still in the lesson. Eh? It's not an app, it's an SP pen. Guys, I don't understand how come you beat me with the ones, but it's fine. look at this, guys. Now we need to test if k is equals to -2, -1, 0, 1, and 2. So those are the numbers that we need to change. Né? These are the numbers that we need to check. So if we find that our answer is between that given interval, which is 0 and 180, so if our answer is between that interval, you know what I'm going to do? I'll accept that answer. Simple. So now let's first start with this one. Eh? For the quadrant 1, let's start with this one. I'm just going to start with this one. I'm just going to write it down. Eh? So remember we said in Q1, x is equals to 90 plus k times 360 degrees. So if we substitute -2 here, what is your answer? Because we need to reject some of the solution. So you're going to take -2, you substitute it where there's k. The answer that you get, if it's between the set x must be an element of 0 and 180. So if whatever that you get is between that, then you just have to accept your answer. But if it's not between, you reject your answer. So the best thing that I can do, look at this. If I substitute 0, this will be 90 plus 0. So I know that x will just be 90. So I'm going to accept 90 because look at 90. It's between 0 and 180. Then I move to another one. Look at this. If we put 0 here, this one won't work. So it won't work. We're just going to leave it like that. Then I'll go to this one. If I put 0 here, I get 60. So those are the easiest answers to get. If you put 0, you get your answer as 60. Then this tells you that x must be equal to, x is equal to 60 and 90 degrees. So these are your answers. Where do we get the k -2? So no, these are just the integers that you can change. Remember the solution said that where k it's an element of integers. Né? Come on, who's this? Buddy, is it for the first time you do Danko? Is it for the first time you do general solution? K, it can be any element of integer. So yeah, k can be any element of integer. So what you have to do, you look at these numbers, you can substitute any, but I see that 0 can make everything easy for me to get my x values. So 0 is the easiest one. Look at this. The reason I did not check this one, the reason we did not check this one is that if we put 0, we have 300. Look at this. 300 is not between 0 and 180, so I'm just going to reject that. Ah, come on, Danko. Are you writing on trigonometry? Welcome, guys. If this is your first time, make sure that you join the family, follow, and we'll make sure that you feel at home. Ah, come on, guys. Say, I'm writing on trigonometry grade 11. If you're doing grade 11, maybe that's why you were asking about the double angle. This is grade 12. Maybe that's why you were asking about the double angle. This is grade 12. This is grade 12. Okay, guys. Let's work because you guys hijacked me, and I think it's Evelyn and Surprise. I think this is your fault. I said if we can reach 20k likes, if we don't reach it, we end the live. And I saw someone said, guys, please tap the screen. Now we have to do another problem. It's fine. Let's work on this one. Let's work on this one. I think it's Surprise. Danko, miss you. All the best. All the best, buddy. Yeah, and I'm tired of it. This is the sine of x minus 30 degrees. You get this in an exam and then you'll be like, how can I solve this problem? This is general solution. Find the general solution of the equation. Find the general solution of the equation. How can we find the general solution? Hmm? Answer my question, is correct. How can we find the general solution? You see? Sisekake. General solution. You have it like this. What comes in your mind? Do we solve the identity first? Which one? Yes, we need to solve the identity, Katli. That's correct. We need to first start by solving the identity. But what is the first thing that you're going to do when you see this type of a problem? Yeah, answer my question is correct. Cameron. Reduce the left hand side. Yo, I want to do the opposite, Katli. I want to increase the left hand side. I'm going to use the identity for sine. So the sine of alpha minus, because it's minus, it's going to be minus beta. We can write this as the sine of alpha, the cos beta. The sine will remain the same. This will be minus the cos of alpha, the sine of beta. So you see why when you work with this, you just have to first check what you have. I have I have a minus b, so I can, what comes in my mind is a double angle. I'm sorry, compound angle for left hand side. Thank you, surprise. That's very correct. So now this is the sine of x minus 30 degrees. We're going to say this is the sine of alpha, it's x, and then the cos of 30 minus the cos of x, the sine of 30. Right. So please let us not forget that this is equal to 3 the sine x. Let us keep that in mind. Okay? Let us keep that in mind. So get in. So now when I have this type of a problem, look at what I'm going to do. I'll say that the sine x, I'll write it as the sine x multiplied by the cos of 30. You just have to punch that guy on your calculator and you'll find that the cos of 30 is the root of 3 over 2 minus the cos of x times the sine of 30 is just half. So this will be multiplied by 1 over 2 equals to 3 the sine x. You just have to flow with the question, apply what you know. Because once you manage to see the first part that you need to use a compound angle for sine, then you are done. This one, when I have this, I can just say this is over 1. Then we're going to row multiply. We'll say sine times the root 3. This is just root 3. The sine x. 1 times 2 is just 2. Minus row multiplied, because this is over 1. The top part will give us the cos x over 2. It's equal to 3 the sine x. Just use your algebra. Go with this step by step. Ne? So the top part, look at this. The denominators are the same. We can write this as what? We can write this as one denominator. So we can just guys, what happened here? We can just write this as one denominator, but at the same time I'm thinking about doing something else instead. I think let us go back, because what we are doing, I don't think this will work. Nah? Let us go back. Let us go back. Instead of row multiplying, I just saw something here. Let us go back, guys, because I see something interesting here. Né? You know what is interesting? This 3 sine x. So I know that I can just write this as the root 3 over 2 the sine x, then bring that one to be negative 3 sine x, because you know why? I have sine x, I have sine x. I can add or subtract these two guys because they are the like terms. That's when I saw that something is wrong. So I need to go back and take this and bring it this side so that I can group these two. These are just like terms. And then let's take the cos to the other side, the cos of that half. I'll explain why we are taking the cos of that half. Remember, the half is not an angle, so we can bring it in front. We can take the cos of that half to the other side to be positive 1 over 2 the cos of x. So now if we add this side, we can have sine x. Let's take it out as a common factor so that I can have the root of 3 over 2 minus 3, and then this is equals to half the cos of x. I hope everyone is still with me on that. Né? I hope you guys are happy with that. Because first thing first, we had this, and I saw that if I bring it this side, I can subtract this two, which will allow me to take out the common factor. So now that I have this, you know what I'm going to do? I have sine, I have cos. So what can I do to get rid of this? Because I need to work with one identity. I need to work with one. So we should make sure we check for like terms first. Yes, that's what happened. That's why we almost got lost, because we didn't check the like terms. Look at this sine. I saw that if I bring it to the other side, I'll be able to take out the like terms. I'm very happy that you guys are paying attention. Né? So look at this. I need to get rid of this. I know that tan it's equal to sine over cos. Né? I know that tan is equal to the sine x over the cos x. Right, so I can divide both sides by that cos x, and then I can divide this by the cos x. So these two cancels. What do we have? We have the tan x that is multiplied by the root 3 over 2 minus 3, which is equal to half. This is equal to 1 over 2. Then I can just divide both sides by the root 3 over 2 minus 3, divide by the root 3 over 2 minus 3. I know guys, I'm not trying to... Okay, so this will be the tan of x. It equals to, you just have to punch this on the calculator, but please, when you punch it on the calculator, make sure that you can put brackets here. Make sure that you put it on the calculator correctly. Né? I'm going to put this on the calculator, and I also request that you guys also try to put it on the calculator. Let's see if we get the same answer. Né? Let's see. I want to see if we're going to get the same answer. Facts, get in. Okay, on my side I got negative 0.234, but I'm not going to round it off. Né? Negative 0.234 and so on. Né? Yes, Kathy, please don't round off your answer. Né? So remember, when I have this, I can find my x, which is my reference angle. So now my reference angle is equal to, when you put this on the calculator, né, do not include the negative. I think I always say this because the negative tells us which quadrant we need to work on. So this will be the tan inverse of that answer, 0.234. Please don't use the rounded off, just say answer on your calculator, just press answer. Né? So now when I have this, I have my reference angle this side, My RA it's equals to 13.19. 13.19 degrees. Okay, I'm happy with that now. So now X it's equals to, I need to choose the quadrant that I have to work on where is tan negative. The negative tells us the quadrant that we need to work on is negative in quadrant 2 and quadrant 4. So in quadrant 2 it's 180, we minus our RA, we add K times 360 degrees. So what is this equals to? X will be equal to 180 minus our reference angle of 13.19 plus K times 360. And what is your answer when you minus these two? Oh yes, thank you very much. For tan we use 189 because tan period is 180, so we're going to use 180. I'm very sorry. You see, Danko, you are, I think you are, man, I think you are, what is this? I think you are ready for your test, man. You are ready. I think you are ready. Yeah, so this will be K times 180 degrees plus K times 180 degrees. So 180, this is 166.81. Thank you, Kamrelo. Thank you, Kamrelo. Okay. Uh, yep. 166.81 degrees plus K times 180. You see, if us with that time we were still in school, if there was like TikTok, if there was sessions like this, we were gonna do well, like well. Even though yes, we did well, but imagine if we had these resources. Pela us, we didn't even know what we call Wi-Fi. No, I only used the Kevin Smith study guide. That's the study guide I was using. But now the study guide that I prefer is Maths for Africa. That one is the best. I don't want to lie. Maths for Africa is the best. When I say Maths for Africa, guys, this is the one that I'm referring to. Né? And this is the best. Believe in yourself because we do Maths for Africa. So now, in Maths for Africa, they just explain everything. Né? They just explain how to choose these are the general tips. They just explain. If you see the sine 2x, you immediately replace sine 2x with 2 sine x because there is only one option for sine 2x. Then they ask you, what do you see before or after the cos 2x? You see, if you see sine x, you're going to replace cos 2x with 1 minus sine squared x. If you see cos x, you replace cos 2x with 2 cos squared x minus 1. And if it's sine times cos, we replace with sine squared x minus sine squared, cos squared x minus sine squared. In order to get a trinomial, okay? So if you see plus or minus 1, you replace the cos 2x with the identity. That will cancel out that 1. Yeah, it's nice, and you know, I like it when it comes to finance. Né? You see, when it comes to finance, it's going to make you like the best. When it comes to finance, you see, the finance questions, the best. When it comes to finance, I don't even want to mention the calculus part. The calculus, I don't want to mention the calculus. How can I send it on the group, guys, while it's like it's a book? You know, when someone is asking how much is this book, when last year it was 180 rand. last year. But this year I went to PNA and then I saw the price. The price was like 220, so it increased with 40 rand. So it's 180. 180, see. You can get it called PNA bookstore, or you can just buy it online. Maths for Africa. One of the best for this one, Fanaka. Trust me. Okay. I think Jabs is here. I see Unjabs is here. So guys, I think you can also work out on the other side. Ne? I think you can also work out. Please just give me a second. Okay, so I guess this is where we're going to stop for today. Ne? I guess this is where we're going to stop for today. Thank you guys for joining in. I wanted to start and say if we can reach 30k, we're not ending the live, but I know the surprise and Evelyn, they're going to Patutezo. Thank you for the follow. Welcome to the family. We'll make sure that you feel at home. Ne? Yeah. You guys are not ready for the program that is starting next week. But if you are not ready, get ready, get ready, get ready. Thank you, Evelyn. We are at the back. Thank you, Lord. We'll tap the screen. No, we are ending the live. If you are not ready for the program next week, get ready, get ready. Part when is the next live? Part 2. If you want to know when is the next live, please get in on the group now. Get in on the group. Then we'll add you on the group. You'll see when is the next live. Tomorrow is Sunday. Tomorrow is my birthday, so I'm just gonna go live in the morning because there's a student that I need to attend. So it's just gonna be like 7 to 8. Guys, I even forgot to stop the recording. You see now,